Hello class, today we're going to talk about volume of prisms and cylinders. So the thing that we're going to attempt to do today is learn how to find the volume of a prism and a cylinder. So we have two vocabulary words that we need to deal with in this lesson, that is cylinder and prism. And what's the difference between them? Right? And why do we put them in the same lesson? Well, for a cylinder, we know that it is a three-dimensional figure that has two congruent circular bases. That's what we know about a cylinder. Okay, so that means we've got a circle base here and we have another circle base here. Okay, so that's what a cylinder is. So a cylinder is known as a can. Is basically what it amounts to. Now a prism, so what's the difference between them? Well, a prism is also a three-dimensional figure. It's going to be named for the shape of its base. So if it has a rectangle for a base, we call it a rectangular prism. If it has a triangle for a base, then we call it a triangular prism, and so on and so forth. The one thing that we need to know about it is that the two bases are congruent polygons. Okay, and that's the biggest difference between a cylinder and a prism. A cylinder, they have bases that are circles, and prisms have bases that are polygons. Okay, so that's the distinction, because a circle is not a polygon. So in this lesson, we will need to try to find the volume of that, okay, or the volume of each of those shapes. And these are the three shapes that we have to know about. We need to know about a triangular prism, we need to know about a rectangular prism, and we need to know about a cylinder. Now a triangular prism, okay, we just said that a prism is named by its base. So the base of this shape is the triangle. No matter what it's sitting on, no matter where it's at, okay, the two congruent pieces are the triangles. And that's what we need to make sure we understand. Okay, a rectangular prism is what we call a box. Okay, a triangular prism is kind of like a tent. Okay, rectangular prism, its base is a rectangle. And it can be any one of them. And then the opposite side would be the other base. And then in a cylinder, we have two circles for bases. Okay, so those are all the distinctions. So what I need us to do is look at the formulas for these. How do I find the volume of each one? Well, we have a generic formula for volume of any kind of a prism or a cylinder, and that is volume is equal to capital BH. So make sure you understand that it is a capital B. So when we have lowercase b, we're talking about just a little base. It's a measurement of one of the shapes, or one of the pieces of the shape. Okay, if we have a capital B, it's actually referring to the actual base itself, and it is the area of the base. So as a result, we take our area formulas and we plug them into our capital B. Kind of like this. Let's say I had a rectangular prism. Well, in a rectangular prism, our base is a rectangle. So we would plug our rectangle formula in, which is typically, first one that you learned was length times width. And then we just multiply by the height of it. So this length times width part, this is the part that's our base. All right, now if we have a triangular prism, we actually have two formulas for this. Okay, we have our first formula that says, okay, this capital B is the triangle formula. So we would have BH divided by 2, or 1/2 base times height, times the overall depth of the figure. Now this formula is a little difficult to understand sometimes because we've got two H's, and each of the H's means something different. This first H is referring to just the height of the triangle. Okay, so it's looking at just the base shape. Well, this height, okay, or depth of the figure, I often call this the depth of the figure, is the distance between the two bases. And that's the big distinction between the two H's. Now, back when we looked at area, we looked at how a rectangle and a triangle are related to each other. And I know that if I have a rectangle of this size, its corresponding triangle is half of that size. Well, that also holds true when we have a rectangular and triangular prism. Okay, so we could actually write this formula as volume is equal to length times width times height, and then just divide that by 2, and you will end up getting the same answer. I'll demonstrate that when we get to a problem dealing with the triangular prism. And then the last shape that we have is a cylinder. Now a cylinder has circles for bases. So our base area formula is pi r squared, and then we just multiply by how tall it is. So now what I'd like to do is I'd like to demonstrate each one of these so that you have an example of how to find the volume of each one of these prisms and the cylinder. So here is our rectangular prism. Okay, so we know that we start off with the formula of capital BH, where our capital B is the base area formula, which we know since it's a rectangle, it's length times width or base times height, and then we multiply by the depth of the figure. So volume is equal to, now our length is this one right here. Our width is the 4. So we would have 9 times 4, and I like to think about these in terms of the base itself, and then I multiply that by the height of the figure. So in this case, times 5. So all we do, we go to our calculator at this point, we multiply 9 times 4 times 5 together, and you should come up with 180. So we've got 180. Now since we're dealing with volume, our label is inches cubed because we are looking at 3 dimensions. Right? So that's how we deal with a rectangular prism. Just length times width times height, which is the same thing that we've dealt with for quite some time. Now let's look at a triangular prism. We're going to look at this one with both formulas. So we'll start off with volume is equal to capital BH, which is our base formula. But this time we're going to use this with a triangle. So I'm going to do base times height divided by 2 times the depth of the figure. Okay, so if we look at it this way, our base and our height of the triangle are those 2 pieces right there, the 2 pieces that are touched by the right angle. So that's going to be 8 times 6 divided by 2. That will get my base. And then I'm going to multiply by the depth of the entire figure, which is the 10. Okay, so times 10. So if we do that, we end up with 8 times 6, which is 48, divided by 2 to get 24. And then I do 24 times 10 to get 240. Okay, so again, it's 240 centimeters, because we do need to put a label on it. But since we're dealing with all 3 dimensions, centimeters cubed. Now I would like to go back and look at this one more time using the alternate formula. Well, we could still do area of the base times the height, but since this triangular prism really is just half of a rectangular prism, we could do length times width times height divided by 2. Because if you really look closely at it, we could actually draw out the rectangle that triangular prism is half of. So there is the other half of that triangular prism. Well, to find the area of that part, the whole thing, it's just volume is equal to 6 times 8 times 10. But I don't want that whole shape. I only want half of it. And if you look back at the other formula, you'll notice that it was 6 times 8 divided by 2 times 10. Well, because we're doing all multiply and divide, it doesn't matter which order you do the multiply divide in because of order of operations. So we can still get 240 centimeters cubed using this formula. Okay, one last shape, and that is the cylinder. Okay, now a cylinder, we start off with the same formula. Volume is equal to capital BH, but this time our base is a circle. So it's pi r squared, and then times the distance between the 2 circles. So volume is equal to, well, the number that we use for pi is still 3.14 times. Now here's the tough part. We have to understand the distinction between a radius and a diameter. Right now what has been given is the distance all the way across the circle passing through the center. That is called a diameter. Okay. But what I need to find area is I need the radius, which is just halfway across. So if all the way across is 12, then halfway across is 6. Okay, so I need radius squared, so that means I'm going to do 6 times 6, because the 2 means I need 2 of them, and then times how tall it is, which is 15. Now we go to our calculator, type that in, 3.14 times 6 times 6 times 15, and we end up with volume is equal to 1,695.6. So our overall volume then is 1,695.6 centimeters cubed. So that's how we find the volume of each of these shapes. And the ones that we've talked about are a rectangular prism, which we just do volume is equal to length times width times height. For a triangular prism, we can use one of two formulas. Either volume is equal to base times height divided by 2 of the triangle, and then we divide that or multiply that by the depth of the figure, the h. Or we can just use length times width times height divided by 2, because a triangular prism is just half of the rectangular prism that it's associated with. And then the cylinder is just volume is equal to pi r squared h, where the radius or the r stands for radius. So until next time.